Welcome to the K Factor podcast, where we turn up the heat on all things fire protection. Brought to you by the American Fire Sprinkler Association, this podcast sparks conversations about the latest technology, trends, and tools shaping the industry. Join the AFSA tech team as we fan the flames of innovation in fire safety.
Welcome to another episode of the K Factor podcast, another unique experience here at convention. We're doing a few recordings, and we have Jack Poole, principal at Poole Fire Protection. Welcome.
Thank you. Glad to be here.
Could you let us know kind of your background and how you got into fire protection?
Well, I won't give you the long version because
Okay.
it's pretty long. But I got into it. I grew up in Maryland. On a farm. Got involved in volunteer fire department. There was one of the guys that was in that volunteer that was taking the fire engineering program at University of Maryland, which kind of is the path that I took.
We won't hold it against you.
Oh, yeah, I know. But I live in the Midwest.
All right.
I'm a fan of OSU. I get it. So anyhow, I ended up going to Maryland and did 4 years there. My first year was at a community college, and I almost flunked out of college because I was riding fire trucks and chasing young ladies and not studying. So I had to get away where I could get some discipline.
You're living the dream.
Yeah, exactly. Yeah, I was living the dream. So when I went to Maryland, I actually lived at a fire station. So all 4 years of my college, I lived at Silver Spring Station 19. When I was in the station, I was assigned a spot on the engine or the ladder truck. And when the bells rang, I was expected to be in the seat I was assigned. So it allowed me to get through school and probably not party a lot, which was probably a good thing because you better not come back to the station drunk because you're going to be assigned on the engine. So did all the 4 years of college. When I graduated from college, I moved to Kansas City, went to work for a large engineering firm in Kansas City called Black & Veatch. Was there 5 years and then started my own firm, Poole Fire Protection. Will be 35 years next year. So truly a family-owned business. My wife and I started it. I have two children. They went back to school at Maryland, both got their undergrad and master's in fire engineering. And Drew got a second master's in engineering management. The two children are basically part owners of the firm now and going to take over the firm one day. But not quite yet because I'm still having fun. And I enjoy what I do. We got a lot of fabulous clients, and we work with a lot of great contractors all across the world. And truly, we have projects all over the world. Currently, about, I would say 60% of our work is outside of the United States, and very little of it's in Kansas City, which is where home is. But we are, both Drew and I, Drew's my son, and I are licensed in all 50 states, plus 2 territories as professional engineer, which allows us to do a lot of work for some of the bigger contracting firms where we can work for them if you need a PE stamp, need shop drawing review, you need some oversight, we can provide that sort of support because we're licensed in those respective states.
Is there other areas that you're specifically in around the world? Are there
I would say
places?
What takes us around the world is Department of Defense.
Okay.
US DOD, and we're really known in the DoD industry for our hangar, our data center, and our hospital work. And the reason why I think we shine on that is because all 3 of those require truly, do I say, engineered and integrated systems. It's not just an office building that has a sprinkler and a plain Jane fire alarm. You got smoke control, you got a variety of different components in all 3 of those occupancies that you're coordinating and making sure the system works. And that is probably one of the most important things, is to do that final testing at the end. We're probably not loved by all contractors because when we get down to final testing, we're going to test every device. And they don't always like to do that. And yeah, when it says you got to do a hydrostatic test at 2 hours for at 200 PSI, and it can't lose any PSI, that's what we expect. It's got my name as a professional engineer on it, and We want it done right because I don't want the liability.
It's interesting. Scan was just talking. That's the last time that you have to get it right before ITM.
That's correct.
So you mentioned data centers. How much have you seen data centers change in the last, 20 years? Are they still a lot similar? Because it feels like, at least the data centers I've been in, we went from it being fairly complicated. You couldn't go buy the stuff off the street to now a lot of the, you use air quotes here for those of you that can't see the video, but the data centers where it's basically parts and pieces you can buy at Best Buy, right? So the big ones, the Googles, the Amazons.
It has changed all the way from the huge data centers to naturally things are getting smaller. Not necessarily the buildings are getting smaller, but the components that do the same computing power is getting smaller. The heat load is increasing. The challenges of the airflow and the circulation, putting detection in the right spot is pretty critical. So we've done, probably 40 modular data centers. Basically taken a bunch of Connex boxes, if you would. It's really not a true Connex box like you see on the back of a tractor and trailer, but it's a similar shape. And they put anywhere from 10 to 12 to 15 of these together and make a building. And they have even tried to build them in the factory, even in installing sprinkler piping and sprinkler heads, shipping it from Arizona to Virginia, and thinking when they get there, it's not all going to be rattled and shaped apart. Well, it is. It was laying on the floor when they arrived. And then when they start adding all of the other components, it was like, wow, you can't have all these obstructed sprinklers. And now that you got all those combustibles above that suspended ceiling, you need sprinklers up there now. So truly trying to understand and walk that fine line of how we do business and how we provide proper fire protection is a challenge. I currently sit on NFPA 45. And years ago in one of the cycles we changed because NFPA, did I say 45 or 75? 75 is the standard. It was very rigid. If you had a data center, it had Halon or Clean Agent or whatever. And what we're starting to see a lot of the codes and standards do today is allow a risk assessment. Allow the design team, the engineers, the fire engineers to understand your risks and your hazards and provide fire protection commensurate to that level of hazard that you're doing. And that's something that has just recently changed, 2022 edition of 409. Instead of requiring foam in every aircraft hangar of Group 1 and Group 2 type, we're now allowed to do a risk assessment. So what are we really evaluating? We're trying to understand, which is the presentation that Dr. Milky and I are given this afternoon, try to understand what is the risk of having a fuel spill while maintaining the aircraft. If I'm not doing, and I'll be simple about it, if we're not touching any part of the fuel system, what's the chances of having a fuel spill? Pretty slim. Well, you say, yeah, pretty slim. Let's say we're only changing the tires on the airplane. So what do you do when you change the tires? You got to jack it up, right? Where do you put the jack stand? By the wing, right? That's one place it's got to go. What's in the wing?
Fuel.
That's the fuel. So what if a tug or one of these great big toolboxes, Billy Bob's walking through and pushing his toolbox that maybe weighs a half a ton, and he runs into
Billy
the jack
Bob or
stand.
the toolbox.
Yeah, Billy both. Billy both. They run into the jack stand. Is that jack stand going to then tip over and poke a hole in the fuel cell through the wing? And now we dump out, let's say, 20,000 pounds, because they talk fuel in airplanes in pounds instead of gallons, but a boatload of fuel on the floor. Do we have a hazard? Yeah. That's why 409 in the early 80s said you need foam. Not that we had a problem of having fuel spills, but because the insurance company said that's a risk. That risk of an airplane, 747 or bigger, that has thousands of gallons of fuel, is it any bigger of a risk if it's parked in the hangar, than 500 cars with a flammable liquid versus a combustible liquid in an airplane in a parking garage. Do we put foam in parking garages? Just because there's the potential that they might start leaking. We don't do that for automobile gasoline, but we are starting to do it for the other fuel. What's the other fuel? Lithium-ion batteries. Because they do just, for some reason, start burning and go to thermal runaway. We're trying to figure that out. It's one of our greatest challenges that I think our industry is trying to deal with is how do we control that fire? Is it a lot of water? Is a lot of water putting it out? Does water put out energy fires, electric-driven fires? The only thing you're going to do with that, in my opinion, you got to pull the plug. You got to get rid of the energy. Granted, a lot of what might be burning are the other combustibles in the immediate area, and that's truly what we're trying to do with a lot of water is to keep the other stuff cool, exposure protection. So I think we have a lot to learn with lithium ion. So I kind of went way around the barn here talking about a variety of different things, but I think that's the challenges that we, the industry, are seeing, and the codes and standards process is allowing these risk assessments and allowing the engineers to really figure out and design what is the best type of sprinkler.
Well, I'm also kind of hoping that those risk assessments allow us to keep up a little better with the potential rapidity of change within these areas like the lithium-ion batteries, because it's changing so quickly, and our codes and standards process, although a good process, does not change as quickly. So by the time we figure it out for one cycle, the technology is completely shifted.
Correct.
And what was working is no longer working. So I'm hoping that kind of helps us keep up with that as well.
Yeah. I mean, the other industry that we struggle with that from a sprinkler protection standpoint is the storage industry. Even go down to as low a level storage as your local grocery store. You all go into your Hy-Vee, your Price Chopper, or whatever it is, HEBs, depending on where you are in the country, and you see the normal stuff on the shelf that's what, 5, 6, 7 feet high? But then what do they pile on the top rack? 3 more cases of potato chips. What's potato chips? That's equivalent to a Group A plastic. How high can you store Group A plastics? 6 feet? Pretty low. Not 12 feet, 2 cases high on top of the storage rack. We did a bunch of assessments for plain Jane grocery stores. Every one of them was out of compliance, either because of how they were storing stuff on the floor where the public goes, or more importantly, in the back room, because they had it stacked into the bar joist, not just to the bottom of the bar joist, but that's right. There's a shortage of space. One day they're selling a lot of potato chips. 2 months later, they're selling a lot of something else, and they need a lot of styrofoam cups. They're light. They're easy to get to the ceiling. That's where they're at, and that's a challenge. So now those grocery stores that were originally designed, oh, this is an ordinary hazard group 1, group 2, whatever. Now we got stuff stacked 12, 15 feet high, and it's Group A plastics. Now we need a what? 0.5, 0.6? I mean,
well, just like every other occupancy, I feel like grocery stores have gone more towards plastic packaging for pretty much everything as well. It used to be a lot more glass and metal, and
correct.
Now we've gone more towards the plastics as well. So I don't.
Yep. Another challenge we see in the grocery stores, where do you buy your charcoal lighter fluid? So that's a combustible liquid. What's it stored in? Typically a plastic container. And in a lot of cases, encapsulated. The individual 12 plastic jugs is totally encapsulated.
Well,
maybe inside
on the
of
other
it.
side of the store from those bottles of water. So, that's
Right.
not helping us out.
Yep.
Yeah, come time for April too. Stock it right up.
Yeah.
Yeah. So you mentioned all of the hazards that you're. First off, I think I want to step back a little bit. What keeps you passionate, and what keeps you up at night?
That's 2 totally different questions.
Oh, for sure.
What keeps me up at night is those contractors that I find that are trying to, and I shouldn't just say contractors, let's back up. Contractors and other engineering firms that are trying to shortchange the system, or owners that just want to do the bare minimum and don't really care about fire protection.
Low cost.
That's what keeps me up at night. What keeps me passionate and doing what I'm doing is the fun and the challenges that we have every day. I was instrumental in getting the risk assessment requirement put into 409, and we are doing a boatload of risk assessments, and we're getting rid of foam. That feels good to me. We're doing an environmentally a good thing. We've taken away the best flammable, combustible, liquid fire extinguishing agent ever made. We're basically throwing it in the trash because the environmental people said, we have issues, it's health hazards, environmental hazards, we got to get rid of it. Now we're trying to find a solution. And we have some solutions, but they're not drop-in equivalents.
Right.
Yet there's a lot of clients that, oh, that's good enough. Or they say, I don't want to take all of that sprinkler piping out of my aircraft hangar. Can't we just use it? And that answer is no, because if you've had a AFFF solution in that piping, you're not going to get the PFAS out of it. It may be good for a day or two, but when that water sets in there over a week, 2 week, 3 week period, that PFAS is going to leach into the water. And if you have an incident and the environmental people show up taking samples of your dirt or your storm drains or wherever it went, I can almost guarantee they will find some levels. Well, how much is too much? That's the key question. But when they're trying to quantify down to the part per trillion, 3 parts per trillion to be exact, how much is that? 3 parts per trillion, to give you an example. If I take an entire football field, whole thing, and then I put a wall on it of 47 feet tall, fill it full of water, pretty big swimming pool, right? 1 drop is a part per trillion. 1 drop of that water, and that's what they're trying to search for in the dirt, in the waterway, from the contaminant from that AFFF foam.
In a place that it existed.
Yes, in a place that it existed. So the larger companies, what we're seeing, they don't want that risk. If I'm at one of the, say, the big airlines, and we've done a risk assessment for them, and we've come up with a solution to get rid of the AFFF and do a water-only solution, which we are doing, they won't use the pipe. And the reason they won't use the pipe is because they don't want that risk of having a water flow, even if it's a wanted event, of somebody sampling the water because they know they had foam at some point in time. Chances are the water coming into the building is going to have PFAS in it.
So are you finding in those risk assessments that going to a water-only protection scheme is easier or more advantageous than trying to figure out the transition to one of the SFFs as an alternative?
Yes. The challenge that I have with an SFFF, when they've tested that product, they've used generally UL 162. And how do they apply that in that UL 162 test? They got a little wand and they kind of wave it back and forth and it puts a layer out across it. That fuel is in a pan, 50 square feet, and it puts out the fire, meets the criteria of that fire test. How do I know that just because that product worked there, that it will work squirting out of a monitor nozzle on a 50-gallon fuel spill on a flat floor with no solid surface or no edges, no barrier?
Right.
And are you going to push it? They say, well, it'll roll over top. Well, where am I supposed to aim my nozzle? A lot of the manufacturers say, well, just aim it about 8 or 10 feet in front of the nozzle so it hits the floor and rolls. Well, how far is it going to roll? Well, it should roll 100 feet. Well, that's a risk to me as an engineer. I need to know how far. Because if it doesn't roll and it burns down the building, they're coming back to me.
And
You
no one's going to
approve
bump
that.
it and change the nozzle
That's
angle.
right.
There's a lot.
I mean, there's a lot of variables with that. What's the fog pattern? How far does it need to oscillate left or right? And you can say the same thing if I'm using like a grate nozzle and having the trench nozzles. How far are they going to flow? Where's the fuel? Where's it splashing on the floor? How's that going to affect my coverage? Am I really going to put the fire out? Now, granted, I can say the same thing with sprinkler flow. But I know, history tells me, that if I got a fire and it gets hot at the ceiling, I got wet pipe sprinklers there, when it gets hot enough, it's going to trip those heads. Those sprinklers, we got a very good success rate these days. And I feel confident that putting a lot of water, as well as having the crash rescue truck or the fire department, which every airport has to have, show up, I feel I'm dollars ahead, safety ahead, environmental friendly ahead by doing a water only and doing maybe some flame detection to give me some early warning. Get the fire department on the road before it becomes a raging fire. Because the research from the NFPA Research Foundation has told us that we don't have fires in hangars. We don't have spills in hangars. From the research, I think we found like one fuel spill that actually resulted in a fire, and it was small enough it didn't even trip the system. So one spill across the world in 60 years from the research data that University of Maryland, the Research Foundation, and Poole Fire Protection were involved with, that's what we kind of concluded. So point is, there's not a lot of spills, not a lot of fires. Are we doing a lot of overkill? And cost and maintenance.
Cost of the what if.
Exactly.
Does not seem to
So the push that we, Poole Fire Protection, are doing, let's understand the hazards and the risk of the activities. And if they got a procedure, let's say it's replacing the fuel pump on a airplane, that when they pull out the old one, is that going to make a mess? Well, there's very safe procedures on how they're supposed to do it. Maybe we need to tweak the procedure a little bit, or maybe that's the one time they do need to back the plane out and drain all the fuel if they're doing that risky of an event, of a maintenance activity. And that's what these risk assessments are allowing us to do.
Awesome.
Are you also finding that a lot of the hangars are already mandating that the planes come in minimally fueled?
Well, that's typically the process anyhow, because when any plane flies anywhere, they never fill it to the max, because they don't want to be carrying that extra weight. So they calculated, hey, what's it take to get from Baltimore to Minneapolis, plus a little bit of safety cushion? That's all we're putting. So when they land, they don't immediately fill it because they don't exactly know where it's going to go next. Even though it's maybe scheduled to go to Kansas City, they might get diverted and have to go somewhere else. So they wait till the end. And if they know it's going in for maintenance, yeah, they're flying in light.
With the lithium ion batteries and the hangars, I'm curious on duration. Like, are you noticing any changes in duration when you're making these changes?
Duration as in water supply,
right.
no. No on the hangars.
Right.
Maybe on the lithium ion. It depends the quantity, depends the conditions. So that's part of that hazard mitigation, understanding the chemistry, understanding how they're stored. And even another key thing, like this data center that we were working on last week, said, what is your state of charge? We maintain our batteries at 100%. That's your greatest risk of having a thermal runaway, is having your batteries when they're 100% charged. So if you would add a few more batteries so you can carry the load and keep them all at 80%, that reduces my fire risk. And they had never thought of that. When we talked to the data center about that, hey, if you would do this, maybe I don't need to do an extra sprinkler density or increase sprinkler density. But since you got this, it increases my risk of having a fire. Therefore, I'm concerned about that. And depending on how they're packaged, how they're stored, some of them have dividers in between modules. So, and it's even got like a Novak 1230 and some type of almost like a clay material. and they're divided that way, if I got some of that, then I'm not going to change my duration. I can live with the durations that I'm finding in 13, but if I don't have that warm fuzzy, then I, as the engineer of record, am probably going to change that duration.
So could you explain this hazard? What's the process in a hazard?
Fire risk analysis or the hazard mitigation, kind of one and the same. So it's truly going in, documenting what you have. What's my hazard? What's my batteries? What's the chemistry? How we're storing it? How we're charging it?
What you're doing?
Yep, what we're doing. Is it in an existing building, i.e. am I evaluating what's my existing system, or if it's a new building, what's my design need to be? So ultimately, we're trying to quantify the hazards and the risk and build the fire protection system, whether that's suppression, detection, separation, means of egress. All of that goes into the equation to making the correct determination of how to protect that facility. And same with a hangar, same concept.
More holistic than just
exactly
protection. Yeah.
So I think it's worth the discussion that we brought up or just had earlier with your power bank in your data center. So you were kind of talking about the scenario that you had. If you don't mind describing that and kind of some of the conversation.
So this was the building probably dates back to the 80s, was built as a data center, has been used as a data center, but now they're going through change. And it has 5 major data halls, which is where all the computer equipment goes. Each individual data hall has a power room. That power room is where the utility power comes into the building from the power poles, the utility company. It also has power coming in from a generator. So naturally, when you lose utility power, lightning strike or whatever that happens in the community, then you lose power. But there's typically a 10-second, should be no more than 10-second for an emergency generator per NFPA 10 for that diesel generator, typically diesel generator, to fire up and carry the load. So for that interim 10-second period, they were installing 2 UPSs, uninterrupted power supplies. Those 2 UPS systems have lithium-ion batteries in them. So they have already built out the power room, making it ready, pulled power to the data center. You'll walk in where the data hall is, or the data center is going to be, just a wide open room at this time. The equipment's not there, but you got power cords dropping down, ready to plug and play. So when we looked at that system, the existing sprinkler system was designed with a density of 0.3. Seems pretty good. That's pretty high density. And it was over the entire area of the room. Actually, it was called out over 2,500 square feet, but the room's only 1,500. So it was truly extra hazard curve, if you look at it from an FBA 13 standpoint. So that was good. So we looked at the hazards and said, hey, where do we need to be? My gut feeling, 3.3 is bare minimum of where we should be. Probably I would feel a lot more comfortable because my ceiling is 25-ish feet above the floor. So it's a tall electrical room, even though most of the equipment is down at the 6, 7, 8 foot level. And we have a lot of cable trays, a lot of other, I'll say, obstructions, even though by definition it's not an obstruction per 13. So we evaluated that system and said, okay, let me see the calcs. So based on the calculations and the quantity of water that was actually flowing and the overflow, typically you get about 20%. So that made our density actually a 0.34. Okay, I got a bonus point. However, those sprinklers at the ceiling are K of 5.6. Is that a good thing? It's code compliant. Probably not a good thing in our scenario. So if I have a lithium-ion battery fire, it's a very intense, high heat release rate type fire, very concentrated, almost looks like a welding arc, a great big welder, if you would, when these things go off. So I figured, given the height, given the type of fire that I want, I need large water droplets. How do I get large water droplets? The bigger the K factor, generally the bigger the water droplet. Why do I want large water droplets? To help penetrate that fire plume. Because as that water is dropping down, if it's a little drip, little drip, it's probably going to evaporate and turn to steam before it even gets to the seat of the fire. We need our water to get to the seat of the fire, not necessarily to put out that kind of fire, but to help cool the surrounding batteries so they don't go into thermal runaway. So that's really what we're trying to do. And the challenge even with that is that UPS had a lid on it. So it's a shielded fire. The batteries are inside. So we said, hey, let's at least change out the sprinklers. So are the sprinklers screwed right into the branch lines? Are they T's? Are they half-inch? Are they 1.5 by half-inch T's? Well, thank goodness they were all on riser nipples. So now we have a 1-inch pipe. So yeah, we got to change out the sprinkler and the reducer. But now we can go to maybe a K11. So we have a fire pump, so called the sprinkler contractor that did the job that I know very well, that is a great sprinkler contractor out of Kansas City, and said, hey, can you help me run some calcs? He said, what are you looking to do? I said, first just put a K8 in there and see what happens. Well, it changed to almost a 0.4 density just by changing the K factor, not changing none of the piping or nothing.
Typically not worried about pressure too.
Yep, and we had plenty of pressure. We still had a minimum of 16.5 or 16.8 PSI at every sprinkler. So now I got plenty of pressure. Okay, let's go to the next step. Let's go to a K11. So I said, let's put a K11, and what I want you to do is run a demand calc. A demand calc. So what is a demand calc? We're all used to running supply calcs. Here's my density, here's my area, how much water do I need at the riser? That's a demand calc. So I wanted a supply calc. I think I said it's a demand calc. I want a supply calc. So a supply calc is, let's give it all the water it's got and see how much water can I really supply to the fire.
It's actual.
The actual delivered quantity of water, so I can back out of that based on those total gallons per minute, given my square feet, how much density do I have? Therefore, if I can just change a few sprinkler heads to K11 and take my density to a 0.6 or a 0.55, that's a brownie point. I'm now doing a lot of good for my client at little money. So that's how we're looking at things. And when we look at that and we say, okay, how are we detecting it? So I go to the sprinkler drawings and it says this system is a double interlock pre-action system. Do we really use double interlock in a data center?
It's crazy.
The answer is
They
no.
do, but
they do.
Yeah.
They do, because I think the data people have gotten to them and scared the daylights out of, we don't want water on and stuff. But like,
Exactly.
I've been saying this for a while, is double interlock to me doesn't make any sense because we're just delaying water onto the fire at that point.
So where does the double interlock really go? My opinion, freezers. Exactly.
Not much more.
I agree with that. So we went to the sprinkler drawings. They clearly say double interlock pre-action system. So I said, okay, give me the fire alarm drawings. Let me see what their matrix says. Well, number one, didn't have a real matrix, had a written sequence of operations. So now I'm looking for the word VESDA because I have VESDA system. I'm trying to figure out, okay, what's the VESDA do? Well, it just said if you get a VESDA detection, just trigger the alarm. And then when I go to the pre-action line, it says double interlock pre-action, parentheses, 2 things have to operate. How does an installing contractor read that design document, or that shop drawing in this case, to know how to program it? To truly do a double interlock, one of the devices has to be what from the sprinkler system?
Loss of air.
The loss of air. It's got to be the low air. So they probably, and I don't know today what the answer is, but they probably got Fire 1 of the VESDA as Action 1, Fire 2 of the VESDA as my 2 systems. So it's basically a single interlock pre-action system. Because you only got one detection. You don't, and that's what I'm going to tell them I want anyhow, because I want the water in the pipe ready to go, because I'm going to have air pressure on it. I'm not worried about a leak. It's not going to leak when I fill it full of water. If so, your air compressor is running like crazy. So
especially with your hydro test. right?
Exactly.
Those are-
Yeah, we're going to make them do a hydro test and really do a hydro test. Just like we're going to make them look at those penetrations in the wall. Make sure the door closes and latches and the gaps around the frame and the gap at the floor level isn't in compliance with NFPA 80. That's part of the complete fire protection system that we need to look at. The separation, the detection, the suppression, it all goes together to make the system work.
Now, while we're on the topic of data centers, are you starting to see more of the push towards water mist? Because I know
No.
some of the mist manufacturers are saying, "Oh yeah, it's great for data centers," and in theory, it sounds good. But we actually seeing that applied in the field, or is that?
I am not seeing that.
Building code makes it tough.
Yeah.
Correct.
The asset protection extra system. And to switch gears a little bit, do you have any
No,
more
I'm good.
on data centers?
No, data center no.
Are you comfortable with where we're at with foam?
No.
No.
The manufacturers have done a great job trying to come up with a solution.
No pun intended.
Exactly. And it does work. But does it work for the bigger fires, given the type of fire that you're dealing with? What I understand, you got to test every concentrate with every type of flammable liquid to make sure it's going to work. It may work on one, but not work on the other.
Well, I think
So-
that's the challenge for a lot of these retrofits is what used to be one foam. Now you might need 2, 3, 4 different foams in a facility.
Exactly. So acknowledging that we do a lot of hangar work, some of the things that we're seeing is, okay, we will just convert our system, our AFFF system, to a fluorine-3 free system. So you can't just do that. Number one, the viscosities are different, the quantities are different,
Proportion.
the poor proportioning, that whole 9 yards. Everything is different. But my concern is, how do I know it's going to work? How do I know, and we touched on that a little bit earlier, that fire is really going to get controlled when I'm bouncing the foam off of the floor? How far is it really going to roll out across that liquid? Because it's not creating a vapor barrier like the AFFF was. You're smothering it in bubbles is really what you're doing. And depending on the rigidity of that bubble may consume some flammable gases. And when it floats into space and it ignites in the air, is that a good thing? We never used to see that with AFFF, but we see that today. So what is my density? What is my concentration? Is 3% enough? What is my duration? Is that enough? But when I talk to the manufacturers, they say, yeah, we're just going to follow what 409 says. 0.1 was good for AFFF, so this is kind of equal and we're going to do it. And I won't accept that because none of them have fire test data, big fire test data. They all got the 162 test, which is 50 square feet, applied with a little wand thing, and it puts it out. But I don't have the confidence level that what kind of nozzle do I need? What type of oscillator do I need? Is it oscillating too fast? Is it staying ahead of the fire? Is it not staying ahead of the fire? There's too many variables, which is one of the reasons why 409 is now allowing a risk assessment. So coupled with all the environmental concerns of the AFFF and even the high X, there's been more deaths from high expansion foam than any other foam. So is that a good thing? It doesn't have the environmental impact, but that's a challenge. I mean, I'm doing some expert witness work where we're dealing with people that have passed away that seems to think I know where I'm at. I know how to get out of this hangar. And they can't. It disorients you. So there is some challenges with any of that. And given the environmental factor that we're in, that the world is in these days, if we can do it with water, that's how we're going to try to do it. Let's control our risk, control our hazards, and suppress it with water.
Not animal protein?
No.
I'm going to bring that, I'm going to bring that back.
Nope.
So
That
while we're
nasty
already
stuff.
opening up cans of worms of challenging fires and changing environments, are you doing much work on ASRS, automatic storage and retrieval systems?
We've done a couple, but once again, they're a major challenge in itself. Because some of the ones that I've seen, they don't necessarily have a designated spot for those potato chips or those styrofoam cups, which are your Group A plastics. They, because of the beauty of the ASRS, it's in this corner today and that corner tomorrow, and it can float anywhere. And how do I get to that deep-seated fire when it starts down at almost the floor level? How do I control that? I think there's a lot of smarter people in the manufacturing side are coming up with some different sprinkler heads, or maybe using the framing of the ASRS system to be the piping system. Kind of crazy, but maybe not so crazy. I don't know. How do you put a sprinkler head in the side of the frame that doesn't become an obstruction? There's a lot of smart people that can probably figure that out too.
I don't know about clearance.
Yep. But there's definitely challenges. And how do we control that? I know, thinking back a few years of trying to have some computer-activated sprinkler heads, maybe that's not too far off. Maybe that might be the right solution for something like that. If we can then monitor, hey, if this one goes off, I want the 6 or 10 or 15 around it to go off. Maybe not a bad idea. And if we got them spaced, maybe we got less water flowing out of it so we can have 20 or 30 of them going off, as opposed to 110, 150 gallons per sprinkler head per minute with some of these large K-factor K25-2s or 28s or 32s or whatever they're at today. That's a lot of water, a lot of pressure. So I think there is some solutions, and that's kind of what keeps it fun.
Yeah.
So between that and the expert witness work is
Yeah.
why I'm
interesting.
still here.
Yeah. Strange question, and since you haven't listened, I think I might catch you off guard here. If you were a type of sprinkler, what type of sprinkler would you be and why? Or type of system. You can go either way.
I think I would be I'm going to say a medium K factor
Okay.
on a wet system.
All right.
And reason being,
So like 11.2 range?
yeah, 11.2 to maybe a 16.
Okay.
16 that was a beautiful sprinkler head. Still is a beautiful sprinkler head. It works in a lot of scenarios. And I like the wet because I'm there and ready to go anytime.
It's a firefight.
You know, I can't really say I'm ready to go anytime anymore, but
A little thought, and then you're good. A little risk assessment.
yeah, exactly. I got to always assess that risk.
Kind of a final question before we close is what do you look forward to most at the AFSA conference and expos?
Some of the new technology and staying abreast of what's happening in the world. It's really hard to stay on top of lithium ion. That's one of today's challenges, as well as the storage. You got people like Wes Baker, James Gollenville, or the Viking team is involved. Those are some of the leaders of doing testing and figuring things out. All very good and kind of which keeps me coming. So the training that AFSA does is a great job. I just sent one of my designers, and we're an engineering firm, so we don't get in the weeds and do shop drawings a lot, but they just went through and sat in your class. Adam was there, and he came back. It is one of the best he's had.
Awesome.
So compliments to you and your team. You do a good job. So, and I know John really well.
Oh, for
so
sure.
you probably know that. I went
Yeah.
to school with John. And John is very passionate about what he does on the stage and talking, and he gets loud and wound up, and I kind of represent that a little bit as well. I mean,
like
because
that in college?
it's the passion. Maybe it was that year of '86. So, but it's having the passion and seeing the challenge is what's keeping me involved. So, and as I mentioned, the expert witness stuff, dealing with some of the fires and trying to figure out why didn't that go off? Why did it go off and it shouldn't have went off? And figuring some of that stuff out. Getting in the weeds is fun. And it pays pretty good too.
Yeah, a little bit. Really appreciate you having you on. 2 reasons. One is you're one of the only Maryland people that understand that a cowboy boot's a lot bigger than a terrapin. Right?
Yeah, that's true.
And the other is I learned so much from you, and glad our listeners get to have a piece of that. And
Yep.
appreciate it.
Well, I appreciate the opportunity. It's been good. Thank you.
Awesome. This has been the K Factor Podcast. If you enjoyed the show, don't forget to like, subscribe, and share wherever you tune in to podcasts, or head over to our website for more. Reach out to us anytime at technical@firesprinkler.org. Stay safe and always learn as we keep the fire protection conversation going.